Welcome, my name is Wamozo Cosmas. I'm going to take you through a review of the stream learning machine-based ensemble transfer learning algorithm for hyperspectral image classification. I'm going to take you through a quick highlight of the abstract, introduction, proposed method, conclusions, and then I'll take you through the references. The abstract, the authors acknowledged that extreme learning machines have been successfully applied in hyperspectral image classifications due to their ability to learn complex relationships between variables and provide accurate predictions using a single layer of hidden neurons. But applying extreme learning machines in hyperspectral image classifications has been restricted by insufficient training data. So the authors proposed an extreme learning machine-based ensemble transfer learning algorithm, TL-ELM approach that retains input weights and biases of the ELM learned from the target domain, and it utilizes the useful instances or the knowledge it has learned from the source domain to iteratively adjust the output weights of the ELM, which is these output weights are used to train the models and then ensemble these training models with their weights for the final classification, as you are going to see. This article particularly focuses on hyperspectral remote sensing. We are going to see as they were taking images from one place called Bavik University, and then they are more of like satellite images. And then and the target domain was Bavik Center. So generally, they use a technology called hyperspectral remote sensing, which provides a way to observe the Earth's space using hyperspectral image classification. Why use hyperspectral image classification? This is because hyperspectral images contain hundreds of narrow bands of narrow spectral bands with a range of electromagnetic spectra. Hence, classification is done on a pixel by pixel basis. Mostly we are used to RGB, and we tend to neglect in classification, we usually tend to neglect the electromagnetic spectra, and yet it's usually available to us and it's very powerful. So hyperspectral images use the electromagnetic spectra, those colors, I think, to classify images. So traditional machine learning methods like KNN and support vector machines have been used in classifying hyperspectral images, but their accuracy is usually hard to improve. It's usually hard to improve their accuracy because they can't model the intrinsic nonlinear relationship between the spectral information in a hyperspectral image and the corresponding materials. So deep learning methods have stepped in. Recently, have stepped in to identify those nonlinear correlations in the spectral information of the hyperspectral image. And their performance is quite high and their accuracy is high, but they require large amounts of labeled data to extract the features, and the training process is highly supervised. And from research, we know that improving the labeled data for training is quite a difficult task in deep learning for hyperspectral image classification, which calls for more techniques, as we are going to see. So in this article, they suggested techniques like transfer learning, ensemble learning, and then combining them together with the extreme learning machines. But let's take a quick look at the transfer learning. Transfer learning, the way the word transfer is, you're transferring knowledge from a particular source domain, usually with high training data, to a target domain, usually with limited training data. You can't do it vice versa. So the knowledge you've learned from classifying hyperspectral images at Bavik University can be transferred And the useful instances from that knowledge can be transferred to classifying hyperspectral images of pelvic center, which is particularly what was done in this article. Ensemble methods allow us to combine multiple learners. You can combine weights, output weights, and accuracies from multiple weak learners for classification tasks. Yeah, and from research, we know that unassembled classifiers is usually significantly more accurate than using a single learner. And extreme learning machine, this is a single layer feed-forward neural network with a single hidden layer. Yeah, as we know, neural networks, from what we know, they have several layers, especially the convolutional neural networks. But the extreme learning machine has a single hidden layer of neurons, and it has a faster learning speed and is quite popular in transfer learning. And it has successfully been applied to hyperspectral image classification. So the authors proposed, based on the problem at hand, which is the limited or insufficient training data in using using extreme learning machine in hyperspectral image classification, they proposed an ensemble transfer learning algorithm based on ELM still, which learns a weak learner on limited labeled data in the target domain using ELM. Remember, like I said, transfer learning, the target domain must have limited data, and the source domain must have a lot of training data. So TELM first learns a weak learner on the limited data in the target domain. Then we using extreme learning machine. Then we use the weak classifier to classify the data in the source domain. If the classified label is the same as the true label, we add that data to the target domain. So you first train or you first learn a weak classifier on the limited data in the target domain. After learning it, then you use that weak learner to classify data in the source domain. If the classified label is the same as the true data, you get that data you've used in the source domain, you add it to the target domain. So you repeat this process. The newly obtained target domain is used to train a new weak ELM classifier, and all the weak ELM classifiers already obtained are used to classify the remaining data in the source domain. Yeah, if the classified label is the same as the true label, we also get that data, we add it to the target domain itself. We keep on repeating this process. Then finally, we assemble the classifiers in each iteration with their output, weights, and accuracies for the final classification, as we are going to see in the flowchart. So in TL-ELM, there's one important fact to note, actually, which is key to this article. Like throughout each iteration, the input weights and hidden biases of the ELM are kept constant, and this is so to ensure that correctly classified samples have the same results. So we can look at this diagram to get a more elaborated view of the algorithm. It's a flow chart. You can, if okay, you can call it an architecture. So as you see, we are using transfer learning to transfer the useful insights or the useful knowledge or useful instances we've learned from the source domain to the target domain. And then we learn our classifier, which is this ELM. We learn it. And then after learning it, we classify data in the source domain. If that data is the same as our true label, we add that data to the target domain. So the outputs of this ELM are used to train other weak ELMs. But this using the same process, we use the output from this ELM to train other weak classifiers. And we keep on repeating this process until there's improved accuracy, and then we are able to get these output weights of these weak ELMs. We combine them, a process called ensembling. We combine the output weights and their accuracies of these weak classifiers for the final classification. Yeah. So for the conclusion, I acknowledge the tremendous job done in improving the application of extreme learning machines in hyperspectral image classification by combining it with ensemble methods and transfer learning. But I kind of feel that there was less attention to challenges of using ensemble methods in classification. One of them being conflicting performance improvement characteristics like model size, reducing complexity of the model, and increasing training speed. So there was less attention given to ensemble classification based challenges. We more focused on ELM based challenges in hyperspectral image classification, and we neglected the challenges, they neglected the challenges that may arise in supervised ensemble, in applying ensemble methods in supervised classification methods. So with that, we can go through the references. I use some articles specifically to do with hyperspectral image classification in deep learning, extreme learning machines, based ensemble transfer learning for hyperspectral image classification. I think the document object identifiers are there. Yeah, that's all I had for you.